concentration problems. So some of these problems you may have seen in like other courses, such as like chemistry or science classes, and these are ones that we're gonna obviously see in this video, using just some of the basic properties we've done with logs. So the first one says the pH level of a liquid is a measure of how acidic or basic it is. The concentration of hydrogen ions in liquid is labeled as H+. And we have a formula that's given for pH, right? So pH levels, you see a little bit in chemistry. A pH scale can run from, goes from 1 to 14, where 7 is neutral, less than 7 is considered acidic, and greater than 7 is considered basic. So for our purposes today, we're just going to be using our formula in finding values or solving for an unknown. When we look at this formula, it can look a little off-putting because there's so many variables here. So I'm going to maybe change these to ones that we know. So a pH is a value. I'm going to call that maybe Y. H+, which is going to be our hydrogen ions, to test if it's acidic. I'm going to call X with that. So if I was to rewrite this as a formula with X's and Y's, you can see it looks a lot simpler of an equation now. We have Y equals negative log of X, which we've graphed things that even looked more complicated than that. So if we kind of change it up a bit, it's something we're a little more used to seeing. So for A, it says, first of all, find the pH level. So we're going to be finding what we called Y. They give you H+, which we're calling X, and we're just going to solve. So if I substitute that in, I don't know what, and this is for part A, I don't know what Y is, but I know the negative log of 2.56 times 10 to the negative 7. If we go ahead and put that into our calculator, I'm going to go ahead and do our calculator here. You can see I have it here already, so negative log, and then parenthesis 2.56 times 10 to the negative 7. We get 6.59. So that's a pH level. So pH is 6.59. So again, 7 is considered neutral if you were doing this in chemistry class. 6.59 is pretty close to 7, so it is acidic, but it's not super acidic, right, because it's pretty close to 7. For part B, it's the same thing. So the pH this time they give us is 3.1. So pH we said was a Y value. We're trying to find hydrogen, which is our X values. And we're going to do the same thing. I'm going to use this rewritten equation so it's a little friendlier to look at. So 3.1 equals the negative log to the X. That negative 1 in front, I'm going to divide by negative 1. And then to undo the log, I'm going to do my inverse. So I'm going to raise it to the 10. Right? So now I have X equals 10 to the negative 3.1. If I put that into my calculator, and I don't have to do anything to solve for a variable, I'm going to get a pretty small number, right? So that E means scientific notation. So my answer, I could actually write it in scientific notation if I want. It's 7.94 times 10 to the negative 4. And that would be my final answer. So it's a pretty small value. The U-tries, we're going to have you try out, but it's almost the same thing. Example 2, same thing with a log, but this time, another application is logs are sometimes used to measure loudness or decibels. So the formula for the loudness is given, and they give you this formula. So I over I naught, or IO. I represents the intensity of a sound, and the I initial intensity is a kind of our threshold sound, is what they're saying here. So they give you a couple things here. They tell you that you know what the initial is. It's going to be 10 to the negative 12. It's a number, just a really small number. So sounds that are defined in terms of that, of how much more intense they are compared to the threshold sound. So in this first example, they're giving you a value for I, which is 4.91 times 10 to the negative 2. Our goal is to find loudness. So this is our formula. L is our loudness. So I don't know what L is, but I'm going to substitute everything in. So I don't know what loudness is, but 10 times the log of I is 4.91 times 10 to the negative 2 divided by 10 to the negative 12. So you can do a couple things here. You might see that you can actually, these are actually using our exponent properties. You could put that together, but you could also put it all in the calculator. So if I wanted to simplify this more, I could. Because you can see if I moved that up to the top, it'd be 4.91 times 10 to the 10 or 10 to the 10th. But you could have even put it all in your calculator too. So if I wanted to put it in, I'd have 10 log 4.91 times 10 to the negative 2. And then I'm dividing it by 10 to the negative 12. So if I go ahead and solve that out, I should get 106.91 decibels. And then with these, you want to make sure you include your unit because it is an application problem, so units need to be in there. The U-try is very similar, so you can try those ones out. You're just substituting those in. And then our last example is talking about an earthquake. So this one, it's with the division sign, but you can also write it like how we wrote the other one. So log of I divided by IO, same thing. So this is when we talk about earthquakes, they talk about the Richter scale. So earthquakes have a rating of 1 or 2 can be barely felt, but 8 or 9 is a devastating earthquake. So you're given an equation. IO is the intensity of a 0-level earthquake. So that means that's like our threshold like before. The intensity is compared to our I naught or IO. So they give you this where I is 6,309,573 IOs. So if I was to, what's the Richter scale? So R is Richter. I'm just going to substitute my value in. So it can look a little intimidating, but when you put it all in, it usually doesn't end up being too bad. So 573, I have an I, initial IO. And then I see that my original formula has IO as well. So with this, these actually cancel out. And you're going to find with the U-try, you don't even need to worry about it because you're just, the IOs are going to cancel out too. So I'm really just doing the log of this value, 6,309,573. So when I go ahead and put that into my calculator, again, nothing really too different. So you're just using your log key. And then when we do that, we should get 6.799 or 6.8. So on a Richter scale, this was a 6.8 earthquake. Right? Once you get a 7 or 8 is devastating. A 6.8 is still pretty up there, but that would be it. If you have any questions, you can feel free to ask in class, sign up for T-Volt time, or go to the center.